divisibility by 9 in this way. The fast way to get the multiples of 9. Here are the multiples of 9. We'll start with 1. We'll start with 9. And go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay? And then after we get to 0, we'll start over with 9 and go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And there you have all the multiples of 9. Okay? And notice about the multiples of 9, what's the sum of the digits every time? 9, 9, 9, 9, 9, 9, 9, 9, 9. Okay? Sum of the digits is always 9. Okay? Any questions on that? All right? All right, now, the first leg of the adventure in factoring, there are many different types of factoring that we have to look at. The first type that I want to look at here is called the common factor factoring. Factoring the common factors. So, looking at page 117, at the top of the page 117 at the top of the page, number 2, it says 7 times x plus 4. And, for example, number 4, let's take a different color. Number 4, it says 3 times 2x minus 5. And for a third color, number 7, the problem says 12 times 2x plus 1. 2x plus 1. Okay? What I'd like to do is use the distributive property and just distribute the 7 to the x, which would give you what? 7x. And 7 times the 4 would be plus 28. For the second example, you'd have 3 times 2x would be 6x. And 3 times negative 5 would be negative 15. And the third one would be 12 times 2x, which would be 24x. And 12 times 1 would be plus 12. Is that right? We all know how to do that. We've done this ever since a couple of years ago, maybe, for some of you. Or at least we've done that for the last 2 or 3 weeks in this class. Now, what if we didn't have this? What if we didn't have this? You'll notice at the top of the page, these were the problems. At the bottom of the page, you have 8 more problems at the bottom of the page. And at the bottom of the page, this is the problem. What we need to do is go backwards with the answer. In other words, instead of me this is going to be like Jeopardy, right? Where instead of giving you the question and you have to give me the answer, I'm going to give you the answer and you have to give me the question. So just call me Alex. And no, don't really. But always give your answer in the form of a question, right? Okay. Now, what's the common? What number is common between these two? What number divides into both 7 and 28? We need to find the number that divides into both of them, the common factor. 7. So what you do, you write down that common factor. Write down the 7 first. The 7 is the common factor. And then you ask yourself, now, put parentheses and ask yourself, what if we take out the 7, if we take out that 7, what factor is left in the first position? X. Okay? And then we got a plus sign. And what factor is left in the second position? 4. Right? Because 7 factor has been taken out, there's a 4 left there. And then check it by saying 7 times 4 would be 28. Okay? Now, look at the next one, number 2, and number 4. The common factor would be 3. Right? The number that goes into 6 and also goes into 15 would be 3. So we put down the common factor. Now, if you took that 3 out, what factor would be left there? A 2 and an x. Is that right? And minus, now if you took out the factor of 3, what would be left here? That was actually 15 is 3 times 5, so it would be 5. All right? For the third problem, what would be the number that is common between 24 and 12?
12.
Okay, 12. Anybody that wasn't looking at the first part of this problem might have looked at that and said 2. Anybody think 2? How about 6? How about 4? You know, there are a lot of different numbers that you could take out of this as the common factor. So what we want to do always is get the largest one. Get the largest possible common factor. Now, what's the common factor that would be the largest one? Like you said, 12. Okay, so you put down the 12, and then you open up parentheses, and if you take out a factor of 12 from 24, what number is left? 2. And an x, right? 2 and an x. Now, in the second position, you've got to have this plus sign right here, and then you took out the 12, so all the 12 is gone. There's nothing left here, it would seem. There has to be something left there, though, doesn't there? There has to be something left there. If all the factors are taken out, then you assume there's a 1 left, and then always check this by going 12 times 2x is 24x, and 12 times 1 is 12. Okay? So that's what I mean by factoring a common factor. If you'll turn the page, I'd like to try 1 or 2 of these on the bottom of page 118. At the bottom of page 118.
Is this considered double jeopardy?
Yeah, right.
Double jeopardy?
Double jeopardy now. All right, go to the next page, page 118 at the bottom of the page, and I want you to understand what these problems are calling for. Number 10, the problem says 3x plus 18y. And it asks you to find the common factor. This problem says find the common factor. What number divides into both of these? What would it be? 3. Okay, no, 3. That's the answer, is 3. All right, take number 13 right below that. Number 13 right below that says 36x plus 42. Do you see a number, maybe several numbers, that divide evenly into both of those?
6.
Anybody say 2? Yes. 3? Yes. And larger number would be 6. Is there any larger number than 6 that would be a common factor here? So what we're going to put is that the common factor is 6. That's the answer, 6. Now we're not factoring it yet. In the first problems, those on page 118 and 119, all we do is find the common factor. Let me take number 14, and then we'll go on to another type of problem. It says 12x squared, and then plus 6xy. Okay? Do you see any factors that are common between these two terms? And there might be more than one factor. Might be some variables as well as some numbers that are common.
6.
The 6 will go into 12, so 6, and also x. So the common factor would be what? 6x. 6x would be the common factor. Is there any question on that? Okay. Now, I recommend that we stop and do a little bit of practice on page 119 and 120. All right, go on to page 121. Turn to page 121, and let's take an extra challenge problem, or a harder one. Take a look at number 62, and the problem says 8x to the 5th y squared minus 16x to the 4th y squared. Now look at that, and tell me what common factors do you see in this?
8.
And an 8, okay? An 8, okay, let's put down the 8, that's a common factor. What other factor might be common here? X. X to the 5th and x to the 4th. Now, when there are different powers involved, you'll find that the common factor is always the lowest power of the factor. So if you've got x to the fifth and x to the fourth, which of those is the lowest power? X to the fourth. So put that down, x to the fourth. And then y squared, well, we got y squared, don't we, as the common factor. So what would you put down? Y squared as the common factor? So that is the common factor. That is the common factor.
Y cubed.
Y cubed. The problem is supposed to, I've been told that my problem is supposed to be y cubed. Y squared, y cubed. What's the common factor between those two? Y squared. All right, thank you. And so then open up parentheses, and what would be left if you took out the 8? And the x to the fourth. How many x's would be left if you take out 4 of them? You got 5 there, and you take out 4. How many are left? 1x. So that would be like x to the 1, right? And then y squared. We took out the y squared, so that's gone. And now this minus sign right there. See that minus sign? What do we do with that minus sign? That minus sign right there, we put it down right there. Minus. Now we took out 8, so what factor is left here? 2. So that would be a 2. And x to the fourth, you took out the whole x to the fourth factor. That factor's already been taken out, so what's left? Y, in other words, just y. Because you had y cubed to begin with, and you took out y squared, that leaves 1y. Okay? That leaves 1y. And now, what's left here would be x minus 2y. That's the factor. And that's factored completely. If you want to check it, what would you do? This times this, and this times this, and see if it gives you the original problem. Okay? All right, next I would like to go to page 123 and run a series of problems by you just to see how you react to this idea. On page 123, I want to give you this concept. What if we have ax plus by? Ax plus bx. Make it ax plus bx. Do you see a common factor there? X. So what do? We put down the x, and what's left? The a plus b. All right. What if I said the problem is a y plus by. Now, what's the common factor? Y. So we put down the common factor, which is what? Y. And y. And what's left would be
A plus B.
the a. See, we took out the y. So what's left is the a plus b. The a plus b. Now let me do a star plus b star. Now, what's the common factor? Star. So you put down the star, and what's left? What's left? A plus b. Okay? What if I had a junk? And I put this junk in parentheses. And then I'd have plus, let's say, b junk. Now, what's the common factor? Junk. So I have to put down the junk as the common factor. And then what's left? After you take out the junk in both places, the a plus b. A plus b. Any questions on that? Okay?
Why is it junk in parentheses?
Well, just because I put it in parentheses, because I'm getting you ready for the next problem. And the next problem is going to be this. A times the quantity x plus y plus b times the quantity x plus y. Now, do you see a common factor in this problem? What's the common factor?
X plus y.
X plus y. You see the common factor. So if we take out the x plus y as the common factor and put down that x plus y, all right, let's take out the x plus y and put it down. Then you'll have to put down x plus y. And what's left after you do that?
A plus B.
A plus b. All right? A plus b. Any question on that? Okay? Now that's factored. And that's why I put the parentheses in this, because I want you to get used to thinking of the variable as being more than just an x or a y. You see, in this case, the variable is the quantity, x plus y. All right? Now,